Are you an SRE? A developer? A quality engineer who wants to tackle the challenge of improving reliability in your DevOps? You can enable your DevOps for reliability with Chaos Native. Create your free account at Chaos Native Litmus Cloud.
Good morning, good afternoon, wherever you are in the world. Welcome to today's session on HADR options for Microsoft SQL Server on AWS. My name is Asif Mujawar. I'm a Senior Database Specialist Solutions Architect here at AWS. So in today's session, what we're going to cover, we'll look at the introduction of SQL Server on AWS, how SQL Server is deployed on AWS and what are the options we have to deploy SQL Server on AWS. Then we'll look into the HADR options on AWS for SQL Server, and then we'll look at ways to reduce the SQL Server license cost on AWS. So let's start with the SQL Server on AWS. The SQL Server on AWS, typically you can deploy in two flavors. So you can deploy on the Amazon RDS for SQL Server, which is our managed service offering with the single click high availability and license included instances only. On the other hand, we have SQL Server on Amazon EC2, which is self-managed VM, so it's exactly the same way what you currently do on premises, and with the manual high availability and license included, or bring your own license instances. Now let's just dive a bit more deeper into what are the options for deploying SQL Server on Amazon AWS. So if you look at the right-hand side, SQL Server on Amazon EC2 is basically all the admin task, which basically doesn't really add any value towards your business processes, such as scaling, the availability, the backups, the patching, the database install and maintenance, and OS level patching, and those firefighting issues to maintain the space or add a space onto the database service. That's basically what you currently do on premises to maintain a SQL Server infrastructure is something you will continue doing so when it comes to an EC2. What we will do, the underlying data center operations, so like power, racking and stacking, the hypervisor level, and the OS install and maintenance. That is something will be offered out of the box on EC2. But whereas everything else, like the OS patching, database install, the database patching, the backups, the HA, the scaling, you need to do that yourself. And this is where RDS comes into play, where all those undifferentiated heavy lifting tasks is what we call it at Amazon, when you don't really add any value to your end user experience in terms of doing the OS level patching or doing the database install and maintenance, or database patching or backups, the HA, the scaling. All these tasks are taken care for you on the other side, which is the Amazon RDS. This comes as offering as a managed service, so it comes just out of the box for you. And what that gives you, that basically releases the resources to focus upon business value tasks and do the high level schema tuning or schema optimization. So that way, they are the tasks which are schema tuning and all of that. Currently on premises will be the last thing you worry about, because you have the production issues, the patching or the backups or the space issues to tackle before you get to these tuning issues. What RDS does, RDS then takes care of everything, those operational issues for you, and leave you to focus on those tuning, which directly contributes to towards your end user experience. So we'll just look at quickly at the features on both sides. So EC2 is supported with either BYOL or being your own license or being your own software or pre-configured AMIs. That is basically virtual machines, or pre-configured options will. The pre-configured options will now have as many versions or editions supported as custom build solution that you might build yourself. So at the moment, how many of you have struggled either because of expenses or just technical challenges in the setting of multi-site high availability option for SQL Server instance? With RDS for SQL Server, it's a simple add check-in as a checkbox. When you launch an Amazon RDS instance to set up multi-AZ SQL Server cluster that leverages synchronous replication between AZs or using database mirroring. We'll dive into this as we go along the session. But if you need a different HA solution like always on or log shipping, then choose SQL Server on Amazon EC2 and then manage that yourself. Both platforms support storage encryption for all edition using KMS, and those of you running Enterprise Edition, you can use TDE on both platforms, the transparent data encryption. If you need to install third-party tools such as Ola Halligan scripts for maintenance plan or use, then run the SQL Server on Amazon EC2. Otherwise, RDS will take care of everything for you. And if you want to take advantage of automated patching, then choose Amazon RDS for SQL Server. Otherwise, you need to manage those tedious maintenance tasks yourself with SQL Server on Amazon EC2. With that, folks, let's dive into the HADR options in a glance. So typically, there are multiple options when it comes to high availability and disaster recovery, but we can categorize them in 3 areas. Let's just say that simple HADR, standard HADR, and mission critical HADR. With the simple HADR, it's a VM level protection where if you have a failover on the hypervisor level, then you are protected at the guest level, but no protection at the SQL Server or guest OS layer. Whereas the standard HADR would take that into consideration, where we'll provide you the VM level protection plus SQL Server instance level protection, plus you'll get the guest OS layer protection as well. And with the basic availability groups, you can have the database level protection as well. Now, when it comes to mission critical HADR, it's a combination of simple plus standard plus what you go in there, you go into the database level protection. Now, what is the different SQL Server protection levels? We'll cover in the next slide, but briefly, it's about what's been protected at what level in terms of your failures, like whether it's at the OS layer, whether it's a guest layer, or it's a SQL instance layer, or the database layer. Now, mission critical HADR will cover everything. Plus, it will give you seconds of RTO with 0 data loss and with the minimum downtime for plant maintenance, and offer you the horizontal read scaling. Now, let's dive into the protection levels as we spoke about. So if you look at the VM level protection of the VM failover, that protects you from the hardware failure at the host itself, or the hypervisor level failures, or if you have a guest OS level failures. Now, if I want to take it to the next level, that's your VM failure is a simple HADR. Now, if I want to take it to the next level, where I want to say, hey, I want to protect my SQL Server instance level failure if my instance is hung. How about that? Now, that's something that can be covered with the FCIs, the failure cluster instances, which we'll dive in now too, in a slide or two, in terms of diving into what the FCIs and what the options are available for you to leverage the high availability at the cluster level, which is the failure clustering instances. Now, if I want to protect my databases, so I protected my hardware, I protected from hypervisor, I protected for the OS level, and also protected for SQL Server instance level. But what if my database gets hung, or my database itself becomes unfunctional? Then how about that? So we have the availability groups or the mirroring that could help you to tackle that scenario and fail over to the other partner. We'll dive into this every single option in a deep as we go through the slide deck. So let's talk about simple HADR. Now, simple HDR, we spoke about VM or guest level failures. So, for example, at the moment on premises, you have the VM running on SQL Server running on a VM that's using the VMDA or VMDK files or the VHDX or RDM files that are hosted on this SAN or vSAN, or if you're on the RDM directly on the SAN, which is presented from the same location. Now, you have the hypervisor level and the hardware underneath. Now, if the hardware goes down, the hypervisor has an issue, or the VM fails, then the VM will move vMotion to the other side, and it will start running on the another hypervisor or hardware level. So it's like a vMotion to the other host to cover yourself from the underlying hardware failure. And this is on premises. This is what currently we do on premises. How about if I bring it to AWS? We have a single AZ deployment. It's basically, you have an AWS volume, that's where the EC2 instance is running, and that's basically, you have an auto-scaling group. It can scale as the demand grows, or at the same time, you have the auto-heal functionality within the VM. So if something goes wrong with the EC2 instance, it will auto self-heal the instance itself, or it will move within the AZ. If the instance goes down, the underlying host has a problem, the EC2 instance will move from one host to the other host, like you have vMotion on premises. Now let's talk about the backup and restore as a simple HDR options. So generally speaking, there are two major types of backups. Those are backing up the entire SQL instance, backing up the individual databases, or that is basically server level backups are usually the hardware assisted. Using the special storage technologies, you can snapshot the underlying storage where a SQL Server instance stores its files. Using these snapshots, you can restore a database instance to the point that you can perform a point in time when the snapshot was taken. The other type we have, that is the database level backup, is a native SQL Server capability and does not need any special hardware. It can be either full backup of an entire database or a differential backup that keeps changes since the previously taken differential or full backup or transaction log backup, which stores the transaction logs and enables replaying those transaction logs on top of a previously taken full or differential backup, and therefore restores a database to any point in time. So let's talk about the two options what we have when it comes to backup and restore on premises versus AWS. So at the moment you have a regular backup plan running on premises. You can have the same thing on RDS, on AWS, for example. You can have daily, weekly full, daily differentials, and transaction logs backup every 15 minutes. You can run the backup on a local volume. You can do the same thing on AWS. You can run the backup on EBS volume. You can move the backups on archive. This is what I currently do on premises. When it comes to AWS, you move the backups to S3. Now, within S3, you have different options available for you to move your backups. For example, you have retention policies of the backup that you need to retain for compliance purposes for more than 10 years. Now, you don't want to stick that backup into an S3 bucket and then pay additional charge just for having those backups in a standard tier. Now, standard tier will have a premium cost to it. Whereas if you move these backups which are not used, say for example, my weekly backups get moved after 2 weeks into infrequently accessed bucket, because those backups are not going to need it anymore. So, and after say 6 to 8 weeks, I'll then move those backups into Glacier. So that way, I'm not constantly paying the premium cost to store the backups. It's always moving to the low cost tiers as the file goes, as the time grows or the backup becomes older and older. We just keep shifting that to the cheap, the cost effective storage where possible. You can basically what you can do is point in time recovery is available using SQL Server backups. You can do the differential backups to diminish the backup time and space, and some of the best practices are every time transaction log is cleared, full backup should be taken. And in AWS, I would rather suggest if you want to do the server level backups, then consider using the VSS enabled EBS snapshots than looking into the backing of the entire database. Now let's talk about the backups on RDS. So RDS supports both types of backups, server level as well as native Microsoft SQL Server DB level backups. So when you create an Amazon RDS SQL instance, it already includes an automated server level backups out of the box. It takes daily snapshot of the entire instance and by default retains the snapshot for 7 days. You could also configure it to another retention period that works better for your needs, up to 35 days. In Amazon RDS, these are called automated backups and they are entirely managed by Amazon RDS. Apart from automated backups, you could also create user-initiated backup. Similar to an automated backups, user-initiated backups are also server-level snapshots of the underlying storage blocks. However, unlike the automated backups, the user-initiated backups are not automatically deleted by Amazon RDS. Even when you delete your entire RDS SQL instance, although all associated automated backups are deleted, any user-initiated backups remain available until you explicitly delete them. This is especially useful if you have compliance requirements that mandate retention of backups for longer than 35 days. You could create an automated job that takes user-initiated backups on a regular schedule and deletes expired backups after a given time, for example, 10 years or 15 years or more. So RDS for SQL Server also automatically takes and maintains the transaction log backups every few minutes. So what that does, that basically enables you to restore an Amazon RDS instance to point in time. Example, you could use Amazon RDS console to restore a SQL Server instance to a specific time into a new instance. In this case, RDS spins up a new SQL Server instance, restores last backup from the specified time, and then replays the transaction logs up to a specified point in time. And the end result is you have an RDS SQL Server instance with all the databases restored to a specified time. Now, RDS also supports the native backups for an individual databases. It allows you to create or restore a full backup, and these backup files are stored in an S3 bucket. The backup can also be a multi-file, which is especially useful for very large databases since the maximum single object size in S3 is 5 gig. So when you're backing up or restoring very large databases, the multi-file backups might be the only possible solution. These full backups can be used to restore SQL Server databases on Amazon RDS instance, or move the databases across RDS instance or migrate the database off or from onto on-premises instances. So that's RDS. Now let's talk about SQL Server on EC2. On SQL Server on EC2, you are responsible to handle some of the backup maintenance capabilities that comes as turnkey solution in RDS, what we looked at. However, in AWS, there are still plenty of options and services enabling you to do that. Server-level backups to translate to EBS volume snapshots, which can be created by invoking single API or through AWS console. The EBS snapshots are incremental, meaning only changes since the last snapshots are captured for subsequent snapshots, therefore saving on storage costs and reducing time it takes to snapshot. EBS snapshot are also a point in time, which means each snapshot captures all the blocks of associated EBS volumes as at the exact time when the snapshot was triggered. When you restore EBS volume from a snapshot, it becomes immediately available for application to access it. So in this case, it means you can immediately bring SQL Server online after restoring one or more of its underlying EBS volumes from a snapshot. So by default, the restore volumes fetch underlying blocks from S3 when the first time when the application tries to read them. So this means there can be a lag in performance while after an EBS volume is restored from a snapshot. The volume eventually catches up with the nominal performance. However, you could avoid that lag by using fast restore snapshot. This feature enables you to get full performance immediately after restoring volume. You could also create a native database level SQL Server backups. It's much more similar to how you do currently on premises. You could have, in AWS, you have highly durable and highly scalable and cost-efficient object store. So that is S3 to store the backup files, and then S3 gives you high durability and high availability. And using different storage tiers in S3, you can also cost optimize your backup solution. You could also use AWS Backup to automate server-level backups for SQL Server instances. Now, AWS Backup manages EBS volume snapshots at regular intervals, and you specify for that that you specify. So, for example, you have a consistent type. So what you need to have for AWS backups is the consistent tagging policy across your SQL Server instances. Now, AWS backups is simple and easy to use. However, to achieve this better consistency for SQL Server DB level within volume snapshot, the best practice is to use the VSS enable snapshot. Now let's talk about the VSS, the Windows Volume Shadow Copy Service. It's a solution that orchestrates the OS and application access to underlying I/O. Now, enabling crash consistent snapshot of underlying storage without any application downtime. SQL Server is VSS aware, therefore you can use VSS agent to snapshot the SQL Server instances. This is made much easier for you to run SQL Server on Amazon EC2. You can use AWS System Manager to run a command, not only to install the VSS agent on your SQL Server instance, but also to invoke the entire workflow of flushing the OS and application buffer to the disk, pausing the I/O operation and taking a point-in-time snapshot of an EBS volume, then resuming the I/O. And all of this, what I just described, could be achieved in a matter of less than 10 seconds and using a single API command through AWS System Manager. Now, this run command document creates a snapshot of all the EBS volumes attached to the target instance. You also have the option to exclude the root volume, as most often the user database files are stored on the other volumes. In case you stripe the EBS volume across multiple volumes to create a single file system for SQL Server files, EBS also support crash consistent multi-volume snapshot using a single API command. So one of the boldest characteristics of the cloud is to either they're large and sometimes rapidly growing environment at scale. If you have one or two SQL Server instances, you could easily log into each instance, schedule a backup job via SQL agent, and somehow manage to transfer the backup files to S3 bucket where they should be restored and retained. However, if you have tens and hundreds of even more instances, scheduling the job on each single instance can alone be quite onerous. Fortunately though, AWS gives you a way to efficiently do such tasks at any scale. So you can use AWS System Manager, State Manager to schedule a regular backups and also have a backup files transferred to a target S3 bucket. So State Manager associations can target individual instances or all instances that have a common tag applied to them. So for example, you can use hundreds of EC2 instances to have tag key called SQL Server Backup or MSSQL Backup and have value of automated applied to them. Now then, using System Manager, State Manager, you can target all of those instances at once. Combining that with the System Manager maintenance window enables you to ensure the backup job doesn't disrupt normal business operations. And at the same time, System Manager also knows the RAID control policies. For example, you can indicate only a few instances should be backed up at one time, therefore avoiding all devices being impacted by the backup jobs at the same time. Now, the System Manager can handle hybrid environment. You can use the same solution to manage your SQL Server instances running on premises or any other clouds too. That's the beauty of System Manager. Now, that's all good about backups. How about restore? So backup is half story. The other half is the capability to restore these backups. Every business needs well-defined, well-rehearsed processes for taking backups as well as restoring them. So restoration procedures can also depend on customers' requirements. Basically, whether the backup files have to be restored on an existing instance, whether the backup was originally taken, or on a different instance altogether, or an entirely new instance should be created for the purpose of restoring this backup. All of these can be defined and automated using AWS System Manager automation document. System Manager automation can create new EC2 instance or identify an instance on which the backups should be restored. Then it can invoke the SSM run command, which instructs the target instance to fetch the backup files from S3 and restore on the SQL Server. Using a proven and tested automation workflow is basically eliminating those human errors during an actual time of disaster, which also reduces the mean time to action and resolution of incidents or change requests. Now that was simple as JDR folks so far. how about standard now? Let's just take it to the next level where we have covered ourselves from guest level failures, or we doing the traditional backup and restore well-tested approach. Now, I want to take you to the next level where I want to cover myself from the hardware failures plus the VM guest level failures plus the SQL Server instances. That's when FCI comes into play. This is something that Microsoft introduced since SQL 2008. That's when they came out with failover cluster instances. So let's look at the typical on-premises implementation of always-on failover cluster instances. So it's typically you have two nodes. One is online, the other one is in a hibernate mode or on a standby, which is sharing the same storage. Either that's on a CSV, SRE, or an FS. So it provides you the high availability at the instance level. Typically, you deploy in a single DC, and resilience gives you against SQL Server instance failures or the OS level failures. Now, Standard Edition only supports 2 instances, whereas you can go up to 50 instances on Enterprise. If I were to do that same thing in AWS Cloud, how would I do that? Now, you have the EBS volume that can be multi-attached to the different instances at the same time, and you can have the Windows failover cluster built on top of those 2 EC2 instances. Single AZ, usually sitting in the same subnet, that gives you resilience against the OS and SQL Server instance level failures. And now you can use it typically in network balancer, virtual IP for WSC, static IP in the same subnet. Now let's just take it to the next level, right? I want to go multi-AZ. This is where I'm going to realize more value, because I'm still running into the single point of failures. Like, and if you look at the single DC deployment, if the entire DC goes down on premises, I have a single point of failure. Similar sort of thing. If I go to the single AZ deployment into EC2, I've got a single point of failure. If the AZ goes down, I can't do anything. So hence the reason we normally recommend customers to think about multi-AZ deployment for mission critical databases where you have lower RTO and RPO and you can't afford a downtime. These databases should be deployed in a multi-AZ deployment. So FCI or multi-AZ, again, you have the storage comes out of the box, or like an SMP 3.0, STD, iSCSI. Basically, what you do is create the multi-AZ on a multi-subnet resilience. Or it gives you the OS level SQL Server failures or the AZ failures. Because of the low latency network within the multi-AZ architecture, the stretch cluster is a practical option, provides higher resilience as compared to on-premises. If you're looking at the stretch cluster, there's a lot of network intricacies that needs to be handled and looked at before you decide to do a stretch cluster. I mean, I've been bitten myself in the past when I did decide to do the stretch cluster, and then there could be a lot of network level issues and blips that could cause a false alarm on a SQL Server and SQL Server to fail over. So hence the reason most of the time on-premises stretch clusters are kind of no practice, but because we have the low latency multi-AZ architecture, implementing on a multi-AZ SQL Server FCI as a stretch cluster is a possibility. Now let's take it to the next level. Like, we have something called a service called FSX for Windows. This is a file share service that is built and optimized for the Windows workloads. So you can, rather than have a multi-attached EBS volume, you can say, I'm going to create a file system, which is where I'm going to store all of my data files, and it just becomes an SMB file share that is attached to a SQL cluster, the Windows cluster. So you're still going to have the multi-AZ architecture here, where your primary instance is sitting in AZ1, your secondary instance is sitting in AZ2, and you create the FSX file share and then you provision it. Now, the good thing about this file share is you can provision the throughput as compared to what you had in the EBS volume, where you have to configure individual EBS volumes to configure throughput, whereas here you get collectively throughput, what I need to achieve as my entire file store. That's a good thing about this. And then you can have a witness file share in AZ3 that can keep an eye on the cluster itself to make sure the cluster fails over and the quorum is protected for any failures, rather than having AZ1 taken care of. So if you have a quorum sitting on AZ node 1, then you kind of end up in a split bin scenario possibly. So to avoid that, you can go into AZ3. That's where the Windows file share system is. Witness file share is. That could keep an eye on the cluster quorum and decide to fail over the nodes from the primary to secondary in a timely manner. So folks, that was the FCIs and the FCI options we have on the SQL Server on AWS. So there's another way we can achieve the SQL Server high availability using the storage level options. So Storage Space Direct, STD, is another Windows technology that allows you to build and deploy software-defined NAS across multiple instances as a converged or hyper-converged model. You can have the SQL Server instance and STD together, or you have STD and a SQL Server on different instances. Now, it supports the NTFS and REFS, and supports up to 16 servers or 400 drives with scale up to 6 petabyte, and this is on ABS volumes. You can do STD on the instance storage as well, using the i3s, the D2 instances. It's a simple to set up, high performance up to 200k IOPS because of the underlying NVMEs. You're using the instance local store, built-in resilience against disk or server failures. Now these are ephemeral. So far we covered about high availability. How about my disaster recovery? Yeah, high availability will give me the protection around the hardware failures. What if my entire region goes out? Or what if my entire DC goes out? What are my disaster recovery options? Backup restore is an option, but backup restore has got higher RTOs and RPOs. I just need to, what are my options for lower RTOs and RPOs? So one of the options traditionally is the log shipping. So this is a typical implementation of log shipping on premises. So typically our option for SQL Server since back in the days of SQL 2000, those who are old enough to have worked on it, I'm being one of them. So with log shipping, it doesn't matter whether your secondary instance is in the cloud or on premises. The secondary database is offline, restoring the logs received from the primary. So log shipping has 4 steps. First, you're backing up the data on your primary instance. That is basically your transaction log backups. Secondly, you're shipping or copying that transaction log backups from the local server or the primary server into a central file server location. And then basically the step 3 is to download that backup file from the central shared location or file share into the secondary server. And step 4 is to apply those transactions or replay those transaction logs onto the secondary server. Now you have full control over these jobs. So you can delay the log copy or log apply to secondary if you have detected some problem with the primary and you don't want to apply those logs to a secondary, you can do so. So you can choose the job schedule as low as 5 minutes when the jobs are the frequency of backups on the primary, copy to the secondary and restore, or you can go as 60 minutes, for example, in terms of log backup and copy and restore. This means it has a direct impact on your RTO and RPO. So be mindful of picking up the schedule. So the best thing is to, when it comes to copying and applying the secondary, the logs on the secondary, it gives you that option of mitigating if there is a corruption or any logical data that has been deleted. Then you can pause it, and then the only thing that you need to reestablish it, the log shipping, if you pause it. Cool. So coming into AWS, if you were to do this setup in AWS, so you have the primary sitting on premises and you want to do a lights on DR, then you have a log shipping. So you can use similar sort of thing where you have the on-premises model, where on-premises you're backing up the data, pushing across into an S3 bucket, and then we are just copying from the S3 bucket and applying it to an EC2 instance, a SQL Server running on an EC2. Now this compute can be very minimal because all you're doing is restoring the data. So it doesn't demand the same amount of compute as primary. Or you can have the AWS instance sitting in primary into AWS EC2 instance, or you can copy the data back into the on-premises if you like. Or you can have a multi-DR, multi-region DR deployment strategy using log shipping as well. But if you're in the same region, I would rather suggest you to do the EBS snapshot, the VSS and EBS snapshot. That is far much more quicker and efficient in the same region to be able to do the disaster recovery. Now we have another option, is Cloud Endure for as a DR. Now, what that is basically, it's a service. It operates at the block level as well as the VM level. It replicates all the blocks in the VM, including app data files at the block level, and it keeps a track of the block changes into the staging environment. These are maintained in the EBS volume. At the time of DR, Cloud Endure enables you quickly spin up the instance with all the apps configured along with its data in your desired region. For example, SQL Server instance will be up and running along with the data ready to accept the connections, and Cloud Endure for DR is a paid service for DR, but when it comes to migration, it is for free. That's something you need to keep in your mind. Now let's look at the basic availability groups, right? The AGs. We looked at the HA in terms of, and the disaster recovery in terms of what SQL Server or the underlying storage level has to offer. Now there is something called availability groups, which Microsoft introduced in SQL Server 2012 to take care of the mirroring, as mirroring is, as we all know, is deprecated from 2014 onwards. So what is basic availability groups? It's basically similar sort of thing what you have multi-AZ, you have FCIs, for example, but it's not really an FCI. So the availability group runs on top of the Windows failover clustering technology, but in FCI you have the shared storage. With availability groups you have independent storage. With the basic availability groups, that is available in the standard edition, and the only limit is 2 replicas, primary and secondary. You can't access your secondary replica, you cannot do a backup on the secondary replica, you cannot run any integrity checks or anything. You cannot upgrade your basic availability groups from, say, to an advanced availability groups. That needs to be, you basically have to drop and re-add. And basic availability groups cannot be part of the distributed availability groups, which we'll cover in a slide or two. So basic availability group, just think as one database. So in the availability groups, it's just another mirroring setup, but it's just underlying we are using the independent storage copies and a failover clustering technology to be able to facilitate the failovers from one server to the other server. And with the basic availability groups, you can only have one database in that availability groups, but whereas compared to the advanced availability groups, you have the multiple databases that can be added in the single availability groups. That's the key difference here, folks. So with that, we'll dive into the mission critical HADR options. What do I have in terms of if I want to achieve low RTO and RPO, and I want to cover almost all possible scenarios when it comes to protecting my SQL Server workloads. So that's when the availability groups comes into play. These are like I said, it's introduced in SQL Server 2012 onwards. It has taken over the mirroring and taken to the next level and combining with the Windows failover cluster technologies. So let's talk about a pattern of deployment. So we have what we looked at in the previous slides with an FCI, where we have multi-AZ deployment with the failover cluster instance, which was sharing the same storage, and the storage was moving between the AZs. Now with the availability groups, you can have independent storage per AZ, and the SQL Server is replicating the data at the instance level. That's basically a synchronous replication with automatic failover, using the same Windows technologies, Windows failover cluster, and then you get an endpoint available for you to application to connect it. So when there is a problem on AZ1, you can simply fail over to AZ2, but the application doesn't notice anything because it's connecting a listener or a whip. So it's seamlessly just say, hey, I was talking to AZ1, database 1, now instance 1, I'm going to AZ2 instance 2, but for the application, it still continue to talk to the database. That's the difference here. So that's one pattern here. So if you look at, this is a multi-AZ within the same region. Let's take it to next level. I want to go multi-region. How about that? You can still do that. So you can have your synchronous replication within the region with the automatic failover between AZ2 and AZ3, but you can add another region and you can create a stretch cluster, goes across the region, and have the transit gate to enable the both accounts within the regions to talk to each other, get the VPCs communicating with each other, and that way you can start replicating the data into a secondary region in AZ1. But this will be asynchronous replication, because you can have only one copy as a synchronous replica. If you're going across the region, it will be asynchronous, and it will be a manual failover. So that's one pattern. What we have another pattern as a distributed availability groups. So what you're gonna have two separate Windows failover clusters in a region A and a region B. And between these nodes, they will talk to each other on a synchronous replication. Now, as we looked at in previous configuration, that we had synchronous replication going from AZ1 to AZ2 in a region A. As soon as we introduce another region, it will be an asynchronous replication with manual failover. But what if I have another cluster which is sitting in region B? Can I do that? Because in the previous example, we had one cluster going across the region. Now we are bringing in two different clusters, so we don't have to worry about stretching the cluster, stretching the AD objects and all of that. So we'll have two different independent clusters. And then that way, what you're doing here, you're going from primary replica in AZ1 in region A into region B, AZ1 as a forwarder. So that is asynchronously replicated, but the secondary replica in region B in AZ2 then synchronously replicate the data between AZ1 in region B to AZ2 in region B, rather than going all the way back to region A, AZ1. So a replica in AZ1 in region B plays the role of forwarder. So you can fail over between two AZs, and then because the requirements you might have to run the workloads 6 months from region A, you can run the workloads from region B. So when you fail over to region B, you still have that same level of protection or what you had in region A. In the previous example, you only had protection in region A, but the region B only had one instance. So that's how you can tackle the another option available for you if you have the requirement to run the workloads from both regions 6 monthly. So let's just go dive into the comparison between AGs versus FCI. So FCI gives you instance level protection for HA and DR, whereas AG gives you depth level protection. In terms of replication, it's fully automated because in a way you can have the hardware storage level replication playing in a play, or your FCI is basically saying the same storage, same master databases that can going across to the other side. Whereas availability groups, you'll have to manually replicate the instance level object, like an example logins and link servers and etc. Scale up and down in FCI is not supported. Is supported, because you can add the extra instance nodes if you like. On AGs, same thing. You can add extra nodes and extra copies. Apart from the basic availability groups. Read scale out, FCI is not available because you can only have one primary and the rest are passive nodes. Whereas the AGs, you have the read replicas available, where you can add reader nodes as well onto the enterprise edition, not on standard. Asynchronous replication, again, you have the FCI, the block level storage. You can replicate the block level storage to the other node or other storage, and you can bring up the storage on the other side, and off you go. Whereas on the AG, it's on the database level. So you can combine the FCI and AG in a one cluster. So some of the things which you need to watch out for is always on FCI in a single AZ for HA and AG on a second AZ for DR. You can use the FCI inside a cluster placement group and AG for DR in a second AZ. You can use the FCI across multi-AZ for HA and availability groups or AG to the second region for DR. Or you can use FCI for HA and AG for read replicas. So failover between FCI and an AG is always manual in terms of when it comes to DR. If you combine these two together, you will not be able to have an automatic failover if you combine FCI and AG together. So look, that was all about havability and a DR on AEC2. Now, how about RDS? How things that work when it comes to HADR and RDS? So you have similar sort of setup. You have a region and you have 3 AZs where app servers are running, and you have RDS for SQL Server running in AZA, for example. All the apps are talking to the AZA. What if your SQL Server instance goes down? Now, we have things like health monitor and self-recovery capabilities in a single AZ deployment that will self-heal the instance itself. It comes back on and it starts working. But what if your entire AZ goes down? And this is where the problem is. You have a single point of failure. Your application sitting in AZ B and C can't work anymore because you lost the SQL Server sitting in AZA, not the instance. The entire AZ has gone down. So you have a single point of failure there. To address that, what we say customers to deploy the SQL Server in a multi-AZ in RDS setup. So similar sort of thing, you have the apps talking from different AZs into AZA, then we create another instance in AZB, and we start replicating the data, mirroring or always on. Now mirroring is anything less than SQL Server 2016, or if you are beyond certain terms 2017, then you will have the always on groups available, be it standard or be it enterprise. So what happens if your secondary fails, like the instance level failure? That's fine, your application is still continuing to talk to primary service, which is sitting in AZA, and it will continue to do so, and application wouldn't notice anything. And once the secondary AZ instance recovers, it will still start receiving the data from the primary server as it had before. Now, what happens if the primary AZ goes down? That's interesting. Now, what's going to happen? You're going to have the failover kick in. It will failover from the your primary role to a secondary instance, which is sitting in AZB. Now, that takes over as a primary, and then all the application servers are started pointing to that new primary. Now here, because you're using the endpoint, you wouldn't necessarily, your application wouldn't notice anything that has underlying database host or instance have changed. It will just continue to work as it was working on the failover cluster instances. The always on availability growth on EC2 or currently on premises with the list name. Similar sort of thing happens here. It will just simply seamlessly failover the applications to the second instance, and your application will continue to work without noticing that instance has been replaced underneath. And once your primary AZ comes back on, or the instance comes back on, we will replicate the data from AZB into AZA. So this is all happen automatically. You don't have to set up anything with a single click. Whereas the options what we looked at so far on EC2, those are built and managed by you. Whereas in RDS, everything is out of the box. You just click one button and under the hood, we will do all that automation of creating another instance, backing up your primary databases, replicating that to secondary instance, and configuring that always on mirroring on top of it, and then allowing you to say, hey, your database is protected now in the multi-AZ. So with a single click. Now, so let's look at the failover timeline. So when you look at the multi-AZ failover timelines on a standard edition with the database mirroring, it's typically 1 to 2 minutes, and because it has DNS propagation. If you look at with always on, it's literally under 10 seconds because there is no DNS propagation. You simply just switch it over to the other side and off it goes. So HADR options, what we looked at so far, we looked at the backup and restore, we looked at the snapshot, we looked at the log shipping, we looked at the storage replica, the cloud NDR for DR, we looked at the FCIs, we looked at the AGs, and we looked at the district AGs group. And these are the options available to you for you to work on EC2. With the backup and restore, you can use that on RDS as well. Or RDS itself has an automated backups and multi-AZs for what we looked at in terms of your disaster recovery HA scenarios. With that, folks, we come to the last topic, which is cloud enables to optimize licensing cost. How we can help optimizing the licensing cost when it comes to SQL Server deployment. So this is a typical scenario on premises. You have an Enterprise Edition SQL Server installed in an OLTP environment, and it has got 2 nodes sitting inside A and side B. Now, in the primary side, you have your OLTP workloads constantly writing the data, synchronously replicated to the secondary AZ, and we have opened up the secondary side for reporting purposes, and you're backing up the data from there. So basically, in a nutshell, as soon as you open up the secondary instance, you need to pay for the licensing for that. So both sites are constantly used, hence the reason you have licensed both sites. So say 6 cores on this side and 6 cores on that side, so total 12 cores implementation with always on AGs on premises. Now let's replicate that into EC2 on AWS. You're going to do the same number of licenses because you have doing the same thing. So there is no improvements on premises in terms of licensing cost. Now let's go into the change a bit. Now what I say is basically my OLTP workloads are coming in the primary, but my secondary instance itself is passive and is waiting to take over. But there is no activity on that instance, so I don't have to pay for the licensing for those. So I only need 6 cores. Now I have got, in this scenario, I can create a snapshot, the VSS snapshot of the secondary instance, and I spin up another instance from that. That could be Enterprise Edition or Standard Edition, depending on what features I need of the and I can only pay for this instance for when I use. So it's basically license included instance, so you don't have to pay for licensing from your own from your own point of view, as it's a license included instance. So you don't have to pay for extra licensing costs when you don't use secondary. And from going from active to passive replica, it may be possible to downgrade from enterprise to standard. So it's basically an option for you to optimize licensing. At the moment, you are only on premises. In previous model, you were using 12 cores. Now you have an option of downgrading an instance addition from enterprise to standard, and you're using 6 for BYOL, whereas the other instance we're using for reporting or the OLAP workloads, you can spin up the instance when you need to, and that way you can control the cost around the SQL Server licensing, or also you can use the license included instances. With that, folks, that brings me to the end of my talk. I hope you enjoyed it as much as I did, and it was lovely talking to you. Have a good day. Thank you.